Moving on to dimensional analysis. So this is what in Gen Chem, what we introduced in Chapter 3. So pretty darn early in the school year, we introduced this idea of dimensional analysis. But we didn't really throw it into full swing and really start pounding it out until Chapter 9 when we started talking about stoichiometry. So you'll hear the term dimensional analysis. You'll hear the term the factor label method. You might even, if you're going onto YouTube and trying to find additional resources, getting a little bit of extra help outside of what I provide, which I strongly suggest, by the way. You're not going to hurt my feelings. I don't have feelings. I'm pretty much a robot. You might see that some people, and very successfully I might add, they use a table method, which I know works. It really does work. I'm not lying. I just don't use it, so I'm not very familiar with it, and so I'm just not going to take time to teach it to you guys in class. But this is going to be the basis for our stoichiometry, which we will be doing a lot of for the entirety of the course. And we're going to have to be able to do this appropriately. We can't kind of like, waddle our way through this and think we're going to get out smelling like a rose. We will be very stinky, and we do not want to be very stinky. So if we consider a straight pin, which if you don't know what a straight pin is, think of like a sewing needle, consider a straight pin measuring 2.85 centimeters in length, right? So we have a number and a unit, right? This is a quantity. The quantity is length, right? Length is the quantity. Calculate its length in inches. Now, I sincerely doubt that you will get a point on anything this simple on the actual AP exam, but I could be wrong. Hopefully I'm wrong. Let's get you a whole bunch of easy points. But you will have to be able to use this concept in a variety of ways. So let's calculate its length in inches. Now, there aren't a whole bunch of reasons for you guys to memorize conversion factors, and the conversion factors themselves is what I mean. Like these statements of equality, right? It's a statement of equality because I'm stating that 2.54 centimeters is equal to 1 inch. I'm stating that they're equal because that's an equal sign. Call them a statement of equality. But there are going to be some that are useful. Your book, and I actually completely agree with your book, says that there are a couple to know, and I would emphasize these ones that would just be useful for you as a human being moving forward. We know that 2.54 centimeters is exactly equal to 1 inch. I've always memorized that 1 pound is 454 grams. If I were to round that one up, it'd be 454 grams. And then for volume, that 1 liter is equal to 1.06 quarts. In fact, when I do cooking, because I cook so much, not really, that I need a little bit more than 4 quarts, right? If I'm going to move on to the next thing, the gallon. However, if I want to convert it to a liter, they're almost the same thing. Notice they're almost the same thing, but it's just 0.06 off. Right, so I think these could be very handy for you to memorize. Outside of those, the information will most likely be given to you by either the question, or you'll be able to get it out of the periodic table, or the list of givens that you will be given on the AP exam. So when we start with the conversion factor, the statement of equality, 2.54 centimeters is equal to 1 inch. You can write two different conversion factors, right? You can write 1 inch over 2.54 centimeters, or you can write 2.54 centimeters over 1 inch. Now, let's remind ourselves, why is this legal? It's because both quantities, this one and this one, meaning this one and this one, they represent the exact same thing, the exact same quantity, length. And in fact, it's the exact same length, right? It's not just the same type of quantity, it's the exact same quantity of quantity. And so what that means is when I actually carry out the division, which this line here indicates I'm carrying out division, it means that this conversion factor is actually equal to 1. So when I go and I use the conversion factor that I'm going to end up using, 1 inch is the same thing as 1 inch is the same thing as 2.54 centimeters, and so this is something divided by itself. It's kind of like 3 divided by 3. You guys know anything divided by itself is 1. And so when I multiply my given quantity by the appropriate conversion factor, I'm multiplying by 1. And anytime you multiply any quantity by 1, you don't change the value, right? You don't change the actual quantity. You might change the number and the unit, but the actual quantity doesn't change, right? So that's the secret behind using dimensional analysis. And so in order to convert the length of this pin from centimeters to inches, we simply multiply the given quantity, which was given to you by the question, 2.85 centimeters, by a conversion factor that you engineer so that it cancels the undesirable unit and places the desirable unit where you want it. For example, we want inches in the numerator. Why? Because we desire it. Right? With every fiber of our being, we desire that. Whatever, that was lame. We want inches in the numerator so that our numerical answer is not reported in the reciprocal inches. Right? We want inches to be not 1 over inches, which would be the reciprocal. We want it to be inches over 1. Now, that means the other value, the 2.54 centimeters, goes on the denominator. That way, you're dividing something, again, by itself, so that cancels out because it equals 1. We get to get rid of those. And so now I put into the calculator because I'm ready to go. So here comes my TI-84 app. And you can find this for free on Android. I believe it's a little bit harder to get one on Apple, on the iPhone, but I believe you can get one pretty darn cheap, something like $5, which is $5 for a fully functional graphing calculator, right? This is just my phone, but with an app. $5 for a fully functional scientific calculator ain't that bad, so I suggest you guys check that out. But let's do these calculations. 2.85 multiplied by 1 divided by 2.54. Now, there's going to be calculator vomit because remember, the calculator thinks that all of these are count values, right? So they have infinite number of significant figures, which they don't. So I see 1, 2, 3, 3 significant figures. But here's the secret about this conversion factor for the centimeters to inches. Both the 1 and the 2.54 actually are exact numbers. They truly are exact numbers. And so infinite number of significant figures, infinite number of significant figures, 1, 2, 3 significant figures. So my answer needs to have 3 significant figures. So 1, 2, 3. What does that 2 tell me to do? Drop all the rest of the digits. So I'll go with 1.12 inches. Dimensional analysis, we have to be able to do this on a regular basis. It's going to be absolutely foundational because remember, we're talking about chemical foundations in chapter 1.